Hi and welcome to Genetics Decoded. I'm Sharon Palmer, your host. Please note that the information we're presenting here is not to be taken as medical advice. It really is just for general information only. If you like the podcast, we would really appreciate if you would go in and like and subscribe. So just push all your little buttons. It won't cost you anything and it certainly does support what we're doing here. Today, we're going to have a really good look at something called fructose, which is a type of sugar. In fact, it's the sweetest of all the sugars. We've been seeing a lot of information for years around sugar and the negative impacts of sugar, and we're starting to see more of an interest now in fructose. Sugar and fructose do not act the same way in the body, so it's actually really important to understand what fructose is doing to the body, especially as our intake of fructose is going through the roof. And fructose is not all bad. It's like everything. There needs to be a balance. If we look historically at the way our body used fructose and the metabolism, it was one of the reasons that we survived things like famine and really unfavorable environmental conditions. So it's a big part of why we're here. But now that we're consuming way too much of it, it is literally killing us. We know that your genetics is playing a really big role around the way you absorb and metabolize your fructose. So stay with us today and really get a very good understanding of what fructose is doing in the body, where fructose is coming into your diet, and if you get a much better understanding of what's happening with fructose, you're going to be able to make much better decisions, but also know that it's got nothing to do just with the amount of calories that you're saving by switching over to artificial sugars. Today we're going to take a deep dive into fructose, the sweetest of all the sugars. And who doesn't like a little treat in their life? Maybe you're on the opposite end of the spectrum where you're a full-blown sugar addict and there's a huge amount of fructose coming into your diet. What we do know, like everything, balance is key, and that is certainly the case for fructose. What is fructose? Fructose is a type of sugar. A lot of people know it as the fruit sugar. So we find fructose at particularly high levels in our fruit, and it's the sweetest of the sugars. If we look at charts that look at the sweetness level, sucrose, which is the white sugar that you would normally put into your tea and your coffee or that you would cook with, has a sweetness rating of 100. Whereas fructose has a sweetness rating of 173. So it is certainly much sweeter than any other sugar that we have. And as the human species, we are certainly drawn to this taste of sweetness. And that can really be where we begin to become undone, is we like the taste of sugar, we like things very sweet, and now here we have the sweetest of all the sugars. We are seeing that our intake of fructose is going up alarmingly. And because we are having so much of it and we are seeing that the impact on our health is quite negative, we really do need to understand what it's doing in our bodies. But why have we suddenly seen that there's so much more fructose in our diets? One of the big reasons is that we're eating a whole lot more sugar. If we look at some of the research, we see that in about the 1700s, on average, people ate about 2 kilos of sugar per year. In the 1700s and 1800s, the intake of sugar increased 1,500%. And that's led us to about, in the year 2000, we saw around about 70 kilos per year per person. So we've gone from 2 kilos per year to 70 kilos per year. That's an enormous increase in sugar, and you start to see why we're having these obesity epidemics and we're having this real risk around type 2 diabetes. But when we look at, why is sugar a risk factor for fructose intake? And that's because if we look at the chemical composition of sugar, sugar is made up of 50% glucose and 50% fructose. So if you've got sugar in your diet, you've got fructose in your diet. historically, if we look at where our fructose intake came from, so if we looked at hunter-gatherer man, he was finding fructose quite sparingly in the environment. It would have been very, very seasonal. At the end of the summer, you were lucky if you came across a fruit tree and it was laden with fruit. You would gorge on it. You were lucky if you came across some honey, and getting hold of that honey was certainly quite risky. You just didn't get it in a jar. We were exposed and we had access to fructose, but it was quite sparing. These days, we've really seen our increase go up, and that's because, one, all of this sugar is coming into the diet, but when you go into the supermarket now, nothing is seasonal. You can buy strawberries and mangoes pretty much all year round. If it's not being grown locally, we'll either import it from overseas where the seasons are different, or we've got to the point now with our storage, our cold storage, that we just put it in there for months and years. And if you walked into the supermarket now and they didn't have like strawberries or certain fruit, you'd be like, why have they not got it? Like, where is the supply? What has gone wrong here? As we've had more seasonal produce become year-round, our intake of fruit has gone up. And people always get really surprised when we talk about how bad fructose is, because there's a lot of fructose in fruit. How can fruit be bad for us? And we're certainly going to examine those pathways and the reasons why. The other reason that we see an increase of fructose is because our overall intake of glucose has gone up. Again, if you look at sugar, 50% fructose, 50% glucose. Once glucose gets into your body, it becomes metabolized, and it metabolizes into sorbitol, and sorbitol metabolizes into fructose. So again, you can see if you're having sugar, there's quite a strong push for fructose levels going up. We've also got to the point where everyone's a little phobic about sugar. We know that it's not good for us. We want to decrease our intake, and we've moved over to all of these artificial sweeteners, of which sorbitol is one. But of course, now if you're taking sorbitol, what you're doing is you're turning it into fructose. And we need to be really careful here when we look at what are we doing with these artificial sweeteners. We're often moving over to them because we're thinking we're going to cut down on all of those calories. Instead of having a can of Coke that's got maybe 15 teaspoons of sugar, quite a lot, we move over to something like a Coke Zero, no sugar, all of these artificial sweeteners. But we have to really understand that it's not calories that we're saving here. We've got to understand these metabolic pathways, because once that fructose is into the body, or once that glucose converts into sorbitol and converts into fructose, there's these metabolic pathways that are being triggered. And you will see as we explore these metabolic pathways why we need to be quite careful about just removing things like sugar and fructose and replacing them with these artificial sweeteners. They're not good for our health for a whole range of reasons. The main culprit for our fructose levels going up is clearly laid at the feet of food manufacturers and our changing dietary habits, mainly because food manufacturers are giving us a lot more choice now, not just around processed foods, but around ultra-processed foods as well. Food manufacturers love fructose. In the 1960s, they figured out how to produce high fructose corn syrup. Now, a lot of you may have heard of this. We see very high uses of high fructose corn syrup in the US, less so in Australia, but we are seeing the amount and increase over time. The reason that food manufacturers love it is, one, it comes back to it is the sweetest of all the sugars. And we know that sweet taste is attractive. We know we become addicted to these foods. So what's better than if you're putting a product in the market and people want to come back and eat more and more of it? So there's this sweet, addictive nature of the product. We know that using high fructose corn syrup also extends the shelf life. So you can put it on the shelf, it's not going to go bad, it's not going to expire and need to be thrown away. and it's really cheap. It's very low cost. So when you add all of that up, food manufacturers, it's just like fructose is like the best thing since sliced bread. And there's a reason that they're using more and more of it as each year, each decade goes by. How much fructose are you having? Like, what's the average amount that, a person is consuming? If we go in and look at some of the research, it has been estimated that an adult will be consuming about 55 grams of fructose per day. If you're a teenager and adolescent, you have the highest intake of fructose across the population. For teenagers, they're consuming around about 75 grams per day, which is an incredible amount. So if you look and you go, well, this is how much we're having, like how much fructose can you have? What's too much? What's enough? And often too, when we listen to podcasts or we're trying to get information, we like these absolutes. If you just do this, it will lead to that. If you just eat this, it will be beneficial. If you don't eat this, it will be beneficial. So a lot of people go, well, how much fructose can I have a day before it becomes risky? It's not an easy question to answer. It's a little bit like asking, how long is a piece of string? And that's because our response to fructose is really individual. We know that our ability to absorb it and our ability to metabolize it resides within our genetics. So for some people, even small amounts of fructose can do them significant harm. I often think of that saying, an apple a day keeps the doctor away. But if you've got something called hereditary fructose intolerance, which we're going to talk about, that apple a day could literally destroy your liver. But for other people, that apple will be fine. So it's very hard to put an exact figure on it. But if we really look and go, what would we want to see our intake around? Probably around 25 grams per day. So adults right now having around about 55 grams, teenagers around about 75 grams, and we're recommending about 25 grams. So a big portion of the population are eating way too much fructose. There are some researchers and some practitioners who like to even push that fructose intake even lower and are recommending around about 10 grams per day. But if you're eating that, the average diet now, it's pretty guaranteed that your fructose consumption is over and above that 25 grams per day. So now I've got you worried about fruit, right? You're like, fructose is bad and I've been eating all of this fruit. But before you raid your fridge and throw it all in the bin and vow to never let another apple cross your lips, we need to be really careful that we don't vilify fructose. And we do this a lot. If you look through our history, we narrow in on a food and we go, oh, that's really bad for us. And then a decade later we go, oh, actually, it's not bad for us. It's pretty good for us. So we need to be careful about just kind of blacklisting foods. And certainly fructose falls into that category. For each of you that are on this planet, your ability to metabolize fructose is the reason that we actually are alive and well. And that's quite surprising, right? Like, how could fructose be a big part of our survival mechanism? And this is why we have to really understand what fructose is doing in the body, because it is really profound. It has got nothing to do with, fructose is in fruit, so it must be healthy. It has everything to do with the metabolic signaling that happens once fructose comes into the body. If we look historically, we know that there's been a number of these mass extinction events. And we know from the research that 2 of these mass extinction events led to a change in the way our body metabolized fructose. And it meant that we survived. It meant that when food became scarce, when it was difficult to find fresh water, the way that our body was reacting to fructose helped us to survive. And that's really, really significant. But what you're going to see is that all the things that fructose helped us survive with, in a time of plenty, when our fructose levels go up, what saved us is now slowly killing us. The main thing that fructose is going to do, it starts to send these alarm signals at an intracellular level. So as fructose comes into the body and it begins to be metabolized, it kind of almost pushes the organism, the human, the person, into this safety mode. It's telling the body, like, there's a shortage of food. Things are going to get really, really tough out there, and we've got to get really good at surviving. There might not be enough food. There might not be enough water. Key minerals are going to get low. You better figure out how you're going to survive this, or you're just going to be toast. And this is really the role of fructose. And again, if you look historically, not having enough food was our biggest challenge. We were trying not to starve to death. Trying to find food, trying to find calories was a really, really big deal. We didn't have the technology like we do today to process and preserve and store our food. Even if you did, let's say you try and, as a hunter and gatherer, you tried to save your seeds and your nuts and you put it in the cave. What happens if the cave got flooded or a bear came in and got rid of it? There was always a risk in keeping those food stores, those energy stores, somewhere in the body. It was challenging, and something could come in and you could lose it. So what's the best place to store your energy? It is in your body as body fat. And this is really one of the key things that fructose is doing. It is really helping us store a whole lot more body fat. And now you can see why it's starting to really impact very negatively upon our health. We're going to really dig down now into what is the role of fructose in the body, and looking at it from a historical point of view, like how did fructose help us survive? And now in an environment where we've got all this fructose, how does it really lead to certain risks of diseases, and how is it negatively impacting on our health? And this is where I was saying earlier that getting this balance right is really important. A little is not going to be a challenge, and in fact at certain periods in our evolution it was very, very beneficial, but now that we've got lots of fructose, it is really a huge problem. One of the things that fructose does is it enhances what we call glycolysis and the storage of body fat. So from a historical point of view, if you were not getting enough food, enough calories, that food was scarce, the ability to take those calories and store it as body fat that you would then live off when there was no food around was very, very beneficial. But if you look at that these days, where we have, not only do we meet our calorie needs, we grossly exceed our calorie needs. And what fructose is doing, so if you're getting some of those calories from fructose, fructose is encouraging the storage of body fat. And this is where we begin to see its really big impact around obesity. The other thing that fructose does is it pushes us into insulin resistance. And most of you will hear that and go, that's not a good thing. It's not good to be insulin resistant. Certainly these days it isn't. But if we looked at what it meant to be insulin resistant when you were starving to death, think of all the things in your body that need the most energy, it is your brain that consumes most of your energy. It uses up 25% of your glucose. Now, if you're out there trying to survive, you're trying to be strategic around finding food, around looking after yourself, looking after your family, you needed your brain to be able to work. If your brain shuts down and you can't think and you can't plan, you're not going to survive very well. And by pushing people into insulin resistance, what it did is it shunted and it gave the brain preference for getting that glucose. So again, it helped us to think, to plan, to strategize. But these days, if we're constantly in this state of insulin resistance, we end up with the development of type 2 diabetes. Fructose also triggers leptin resistance. Now, Leptin is a hormone that is produced by your fat cells. And when we become leptin resistant, the brain kind of thinks that there's very little fat around, and what it begins to do is it becomes very conservative around burning energy. So again, it was a mechanism for saving calories, for preserving energy. But when you're leptin resistant, you start to get these incredible hunger signals. Like, because if you're sitting in your cave and it's miserable and you're starving, you've got to get up and you've got to get out and you've got to find that food. So what it did is it really triggered this absolute desire to forage and find food. You get this persistent hunger. And then let's say you were lucky, you killed a woolly mammoth, or you came across a big store of food, is that you could then consume a lot of calories really quickly because all of these satiety signals were not working. So it's this strong desire to find food. When you find food, you can eat a lot of it because then, of course, you can store it as body fat. But if we look at leptin resistance now, what that means is if you're overweight and you're trying to go on a diet and you're trying to restrict your calorie intake, maybe make better choices around the food that you're eating, and you're getting all of these signals to eat and eat a lot, it becomes very, very difficult to stick to that diet. And it also means that when you do start to binge and you begin to eat, you don't have that off switch. And so you start to consume a whole lot of calories. And again, that's a big part of why people really fail on diets, is that they can't control their appetite. They can't control their food intake. It's a big risk now to be leptin resistant. We know that fructose increases the storage of fat in our liver. And again, it was there so that fat could be a food supply. It could be burnt for energy. But now, if you're putting a lot of fat in your liver and you're doing that repeatedly, you're going to end up with fatty liver disease. And the number of people I see in clinic that have got non-alcoholic fatty liver disease is actually quite alarming. And if that's something that you've been diagnosed with or you know someone with, one of the things you really need to go in and assess is how much fructose is coming into my diet. And that means you've got to ask yourself how much sugar is coming in, because there's a lot of fructose. It's really encouraging the liver to store this body fat. Fructose helps the body to conserve water. Again, these days we just go to the tap, we turn it on, we've got our bottled water wherever we go. We have no concept really of what it's like to not have this easy supply of fresh water. But again, if we look historically, trying to find clean sources of water could be very, very difficult, particularly in winter where things begin to freeze. What fructose does is it helps to conserve water in the body, and it does it through some really interesting mechanisms. It helps you to retain sodium, and again, that helps to control the amount of water loss. And the other thing too is when you're starving to death, and it's not just calories that you're missing, you start to become very deficient in key minerals, which impacts on electrolytes in the body, and it can become very difficult to maintain your blood pressure. Look at people who go on diets, or these people in starvation mode. What happens? They get really dizzy. They can't stand up. They faint all the time. And so this ability to maintain your blood pressure and keep you upright and keep you functioning was really, really important. So holding on to that sodium supported that. But what about now? All of that excess sodium is not helping to keep us alive, it's pushing us into the realm of hypertension. So it starts to become really, really problematic in the body. One of the other things that fructose does is it increases something called vasopressin in the body. It's a very important hormone around, again, blood pressure control. As vasopressin increases, we have this increase in blood pressure, and it also helps to prevent us losing some of that fluid. So again, it becomes this conservative mechanism, but of course, we lead to that same issue around high blood pressure. Fructose helps to stimulate what we call our innate part of the immune system. So we've got two parts of the immune system. We've got the innate and we've got the adaptive. The innate immunity is more around protecting us from pathogens, bacteria and viruses. So you can see is if there's not enough food, there's not enough water, the whole organism, its function begins to decline. And one of those functions that is at risk is your immune system. And of course, this was pre-antibiotic time. If you got an infection, it literally could kill you. When the body is starting to become very vulnerable and very weak, we don't want to die because we've been exposed to this nasty pathogen. So what fructose did was help to increase the activity of the innate immune system, so give us some heightened protection against these pathogens. But in today's world, when this is something that's happening all the time, we want a balance between the innate and the adaptive. And what we end up is with this chronic immune activation in ways that are not good long term. Fructose changes the way that your mitochondria produces energy. And when you're running out of calories, what you don't want is your body using up a lot of energy. You want to really begin to slow down that basal metabolic rate. And of course, that can make you feel a little bit sluggish, not very much energy. When we look at fructose, through certain mechanisms and through certain hormones being triggered, we can see a downregulation of mitochondrial ATP energy production by up to 60%, which is really significant. But again, if this is something that's happening on a chronic day-to-day level, what you're starting to see is that cellular energy is not being produced, and it leads to just feeling flat and fatigued. We also know that as the mitochondria ATP energy production is downregulated, the mitochondria is encouraged to burn fat for energy. And again, this is where you start to be able to rely on those fat stores. But the other really interesting thing is as you begin to burn fat for energy, you begin to release water into the body. So this was another way to try and get some water if you didn't have a supply. So you look and you go, the body is really, really smart. And fructose is impacting on all of this in ways that were really profound and allowed us as a species to survive some very challenging times. But now we've got so much fructose coming into our diet. It is negatively impacting on our health. It is behind obesity and diabetes. It's impacting around things like dementia and cancer and high blood pressure. This is why you've got to be very careful about putting too much into the diet. Earlier, I talked about how genetics is playing a really big role in how the body is kind of absorbing and metabolizing our fructose. And that's what we're going to look at now, is let's kind of look at the fate of fructose as it comes into the body and how our genetics can really change that. So let's say you had a can of Coke, the real deal, with your 15 teaspoons of sugar. Maybe you had an apple, or maybe you've taken some honey and you've put it on your yogurt because you're thinking this is a great alternative to just sugar. All three of those food sources are going to be introducing fructose into your body. And it doesn't matter really kind of how it comes into the body, the fate of that fructose will be the same. So one of the things that's going to happen is your fructose is going to end up in the small intestines. And What you want to be doing is completely absorbing all of the fructose that you eat. It should be in the small intestines and you should absorb it across the intestinal wall. There is a particular transport protein that absorbs your fructose. The name of that is called GLUT5. That's GLUT and the number 5. And we know that the activity of that transport protein varies from person to person. Some people, that transport, that protein that is absorbing the fructose is working too slowly. It doesn't effectively absorb that fructose. That fructose, instead of being absorbed completely from the small intestines, ends up in the large intestines where it doesn't belong. And that's where you can start to get a lot of gastrointestinal type symptoms. You can get kind of bloating and cramping and diarrhea and constipation. You can get SIBO. For any of you who are following the FODMAPs diet or have tried it in the past, the FODMAPs diet is actually trying to manipulate the amount of fructose that is coming in. It is trying to decrease that. But, you don't know, is it working well for me and I need to be careful with this for a long term, or, can I have a certain amount of fructose? And this is where genetic screening can be so useful, is you can find out whether you really are poor at absorbing that fructose across the intestinal wall. And, and it comes back to the amount, little bit of fructose coming in, even if you're a little bit slow to absorb it, if there's not a lot, you may be able to absorb it. But as you start to put more and more fructose in and it's coming in multiple times a day, it becomes so much less likely that you are going to absorb it and it's going to end up in the large intestines. You're going to have a lot of fallout from that. You've got your GLUT5 that transports it across the intestinal wall. Once you've crossed it across the intestinal wall, you have another group of proteins whose job it is to take it out into the blood and to deliver it to the parts of the body that are going to use that fructose. And that transport protein is called GLUT2, GLUT2. And just like for GLUT5, people can have genetic mutations in that gene in which they are not effectively transporting glucose out into the system. And again, you can go in and you can screen. And people can have every and any combination. I've seen people with problems in GLUT5 and GLUT2 or one or the other. And again, you can just go in and you can clearly define that. The main place that you're going to use your fructose is your liver. There's other tissues that can metabolize your fructose, including things like the sperm, but your liver metabolizes 80% of your fructose. So when you start to talk about all the negative effects of fructose and the change in fat storage and fat metabolism, the liver is really a major target. And that's why I'm saying if you've got things like abnormal liver function tests or you've got fatty liver, you really want to go in and look to see how your body is absorbing and utilising your fructose. So once your fructose gets into the liver, ideally, it is metabolized into metabolites that are going to support you around energy production. And there's a particular enzyme that does that conversion. And again, how well that enzyme is working is genetically determined. Now, people who have a problem with this enzyme in the liver not working well, they are the people who have what we call hereditary fructose intolerance. The people who have a problem with the GLUT5 and the GLUT2, so with the absorption and transportation, are what we call, they have a fructose malabsorption issue. And those two things are not interchangeable. They are completely different, and the impact on the health is very different as well. If we look at hereditary fructose intolerance, there's not a lot of people where that enzyme is not working. I've been doing screening for fructose for about 13 years in clinic, and in all of that time, I've seen less than 5 people who have a problem around the function of this enzyme. But for every single person that we identified as having a decreased enzyme activity, not one of them had ever been diagnosed with hereditary fructose intolerance, or that it had even come up that they had problems in that area. All of them had long-term issues around their health. They would often have a real aversion to anything sweet. Particularly, I'm reminded of one patient who came in. She was, I think, in her 40s when we saw her, and she had the double mutation, which means that she had, the complete hereditary fructose intolerance. She wasn't just a carrier. And she had mentioned that when she was an infant and her mum first fed her some pureed fruit, she just threw up. She got really, really sick and she threw up. And then every time she had something sweet, that happened. She just stopped really eating a lot of sweet foods because she didn't know why, but she knew that it led to these really awful outcomes. And it's quite surprising that someone could get to, in their 40s and nobody has kind of even twigged that may be an issue. There is a push when we look at genetic screening in newborns to put screening for hereditary fructose intolerance on the top of that list. It's not common, but the impact on our health is really significant. It can lead to things like seizures and comas and even death in some people, but it can certainly create and do a lot of damage to the liver and also things like the kidney as well. So some people are not very good at metabolizing that fructose in the liver. And the reason that it's so damaging is that you end up building up this very toxic metabolite. It's called fructose 1-phosphate. And if you can't metabolize your fructose, this builds up and builds up in the liver, and it's really, really damaging. And that's why the people who have hereditary fructose intolerance almost have to have no fructose at all. They have to really, really limit their intake. And that's difficult because, fructose is in a lot of fruit and veggies. They really have to stay away from sugars and sweeteners, and they have to be very careful with their selection of fruits and veggies. For people who have the fructose malabsorption, then they've still got choices. They need to be careful with the amount, but they don't need to be anywhere near as strict as the people with hereditary fructose intolerance. The main take home that I would like you to think about today is that if you're eating too much fructose, it is not good for your health. It would be advisable to do your genetic screening and look to see whether you've got issues around fructose malabsorption and maybe even some risks around hereditary fructose intolerance. But the main thing is, and I always say to my patients, that we should all be looking at decreasing our intake of fructose. And don't start with the apple. Oh, I've just got to stop eating apples. Start with your sugar intake. There are no benefits to your health in having all of this sugar. You want to get rid of as much of it out of your diet as is possible. Then you need to look at what we call your hidden sugar. And again, this is where food manufacturers they're burying so much sugar in our food. And don't think, it's just the cakes and the cookies and the lollies. It is, in all those savoury products, your breads and your wraps, there's a lot of sugar in there. You need to start looking at your labels. A lot of people are consuming a huge amount of hidden sugar. Then you need to look at the amount of, sweeteners that you're using. Are you using things like your sorbitol that can convert into your fructose? Stop drinking fruit juices. I'm not sure how they got to be they're health foods and people, doing all of this juicing. You're removing all of the fibre. Your fructose intake is really high. Drink water. Stay away from fruit juices and sweetened beverages. And then you would want to start looking at the overall intake in your fruit. Fruit has a lot more fructose than veggies, and kind of work your way down that list. But, start with the really big risk factors, the obvious sugar and the hidden sugar in our diet. We've had a lot of people contact us as we've been putting these podcasts in, inquiring as to how can I get this genetic screening done? If you're having trouble kind of sourcing that where you live, please contact us through our clinic. We're called iDNA Health. We're based in Western Australia, so right in WA, but our client base is all over the world. We are completely set up for online consulting. We have patients in the Netherlands, in Canada, in the UK, and so it doesn't matter that you don't live here in WA. If you've done your 23andMe and your ancestry, we can take their raw data file and upload it into our system. You wouldn't even need to get your DNA. And if you haven't got a DNA test, again, we're equipped to post that out anywhere in the world. So if you're really interested in finding out around your fructose, your ability to absorb it and metabolize it, then contact us. But if you're interested in any of the other things that we've spoken about in the podcast, again, just get in contact with us. We would be more than happy to support you here. I think going down and using your genetics to underpin your understanding and the choices around your health is very, very powerful. Thanks for listening to the podcast today. If we've started to increase your interest around clinical genetics and you think you would like to find out a little bit more, please feel welcome to reach out to us at iDNA Health Clinic. We're proud partners of this Genetics Decoded podcast. It's a real opportunity to get in touch with us and find out how you could go down this pathway yourself. If you liked the podcast, enjoyed it today, please go in and push all the buttons, like and subscribe. It really does make a difference and supports what we're trying to do here. We have a podcast release every Monday, so keep a watch out. All of our topics are around genetics and health, and we would love you to join us every week.